Hello again, Year 12. Welcome to your second video. Hope you're still awake. Rinny, wake up. Maths is fun. Okay? In this little video, we're going to look at how to integrate two functions. The first function is how are we going to integrate 1 over x dx. And the other function is going to be how do we integrate e to the x dx. So if we look at this one first, let's just review. Let's say I wanted to integrate 1 over x squared dx. Well, we know that that can be rewritten as the integral of x to the minus 2 dx, which then integrates to x to the minus 1 over minus 1 plus c, which is minus x to the minus 1 plus c, or even minus 1 over x plus c, if you really wanted to write it like that. Okay, so that's one example with negative powers. Let's look at another one. Let's say I wanted to integrate 1 over x to the 5 dx, which is the integral of x to the minus 5 dx, which integrates to x to the minus 4 over minus 4 plus c, which is minus x to the minus 4 over 4 plus c. Remember, ideally we'll be writing the negative sign at the top of the fraction. Okay? And if you really wanted to, you could rewrite that final answer as minus 1 over 4x to the power 4 plus c. Okay? Let us look what happens when we try and integrate this one using the same techniques. So again, get rid of this. Well, if we write 1 over x as the integral of x to the minus 1 dx, then using our normal rule, power goes up by 1, so it'll become x to the 0, and we divide by our new power. Dividing by a 0, it will blow up. Little piece of artwork for you there, nuclear mushroom cloud. Okay, you cannot divide by 0, it does not work. So something is going to have to change. We cannot integrate 1 over x like we do other negative powers of x. However, we have already seen something that is going to help us integrate 1 over x. If you remember, differentiating ln of x, log of x, that gives us an answer of 1 over x. Now, seeing as differentiation and integration are opposites of each other, that must mean that the integral of 1 over x dx must actually be log of x, and don't forget plus our constant of integration. Okay, differentiation and integration are opposites, so if log differentiates to 1 over x integrates to log. The only extra thing you need to know or remember is that logarithms do not work if the number inside them is negative. You can't do log of a negative number. So we actually say that the integral of 1 over x is log of the modulus of x, and remember the modulus function turns anything into a positive. So modulus of negative 3 is just 3. So it gets rid of that problem for us. Okay, so you need to know this. So please make sure you write it down somewhere. Okay, the other one we want to look at, integral of e to the x. Well, again, just get rid of all this stuff. We already know that if you differentiate e to the x, it just stays the same as e to the x, which must mean that if you try and integrate e to the x dx, it will integrate and it will stay the same. But, as always, you get your constant of integration when you're doing an integral. So the integral of e to the x is nice and easy. It is still e to the x. So write that one down as well. So let's just look at one little example. Let's get rid of all this stuff. So let's say we wanted to find the integral of, let's say 5e to the x plus 3 over x. 3 over x. Now let's make it even harder. Minus 6 over x squared dx. Okay, I'm actually going to rewrite this as 3 separate integrals just to make it a little bit easier. So I've got one integral, 5e to the x dx, plus another integral, 3 over x dx, minus another integral, 6 over x squared dx. And the reason I've rewritten it as 3 separate integrals is because now I can use our little rule that we saw in the first video. I can take these constants outside, which makes life a lot easier. So I'll rewrite this as 5 times the integral of e to the x dx, and this one as plus 3 times the integral of 1 over x dx, and the last one as minus 6 times the integral. I could write 1 over x squared, but I'm actually going to write it as x to the minus 2 dx. So you actually need to recognize 1 over x integrates to log, it's a special one, but any other power of x on the bottom you just integrate as normal. So let's shrink all of this down and integrate each piece. So the integral of e to the x we just saw is just e to the x again, so you get 5 e to the x plus 3 times the integral of 1 over x, which is log of modulus of x. You have to remember that modulus sign because it has to be positive, minus 6, and then x to the minus 2 becomes x to the minus 1, divide by the new power of minus 1, and then plus, again, as before, I've got 3 constants of integration from doing 3 integrations, but 3 constants added together are just again going to give me one big constant, which I'm just going to call c, just because it's easier. So I'll shrink this down one last time to tidy up my final answer. So the final answer becomes 5e to the x plus 3 ln of mod x. 2 minuses cancel, so minus 6 x to the minus 1 plus a constant. And if you don't like minus 6 x to the minus 1, you could rewrite it as minus 6 over x to the power of 1, or just x. So there's your final answer. So in this one, just to recap, we split up a long integral into 3 separate integrals so that we could use our little rule about taking constants outside, and we saw how to integrate e to the x here, and 1 over x. Okay, so again, you need to know all of this for tomorrow's lesson, so I hope you enjoyed it. Well done.